Find the second derivative of xy equals x cubed minus y squared plus 4. To find the second derivative, we have to start by finding the first derivative. To find the first derivative, we have an implicit equation here. We have x and y related to each other through an equation, but it is not solved for y in terms of x. And it's not possible to solve for y in terms of x, at least not simply. And we will therefore take the derivative implicitly, and this is done by taking the derivative of both sides with respect to x, indicated by a prime on both sides. On the left side we have a product rule. The derivative of the first is a 1 times the second left alone, plus the first left alone x times the derivative of the second. The derivative of y is y prime. On the right side we have the derivative of the first term. It's a power rule, 3x squared, minus the derivative of the second term is also a power rule, but then we have to multiply by y prime to complete the chain rule. Every time we take the derivative of a y term, we have a y prime multiplying it because of the chain rule. The derivative of the 4 is a 0. So I have y plus xy prime equals 3x squared minus 2yy prime. I can solve for y prime by moving the y prime terms to the left side and moving all the non-y prime terms to the right. So I will add the 2yy prime over to the left, and I will subtract the y term on the left over to the right since it does not have a y prime. We can now factor y prime out. And we can divide both sides by what's inside the parentheses on the left side. To give us the first derivative y prime. The second derivative is found by taking the derivative of the first derivative, so y double prime will be the derivative of that right side, which is a quotient, so we will use the quotient rule. The derivative of the numerator will be 6x minus y prime times the denominator left alone, x plus 2y, minus the numerator left alone, 3x squared minus y, times the derivative of the denominator, which is 1 plus 2y prime, all over the denominator squared. So there's our second derivative, y double prime, in terms of the first derivative, y prime. We will be replacing every y prime with the expression we have for y prime. But before we do that, let's start by distributing the x plus 2y into here. And that will give us 6x times x plus 2y minus y prime times x plus 2y. And then I will distribute the negative 3x squared minus y into here. So the first thing it multiplies is a 1, which will give us a negative 3x squared minus y. And then it will now multiply a 2y prime, which will give us a, I will write the 2y prime first. A negative is distributing in with it. And then the 3x squared minus y. And all of this is over the denominator left alone. So y double prime will equal to, I'm going to distribute the 6x in here, which will give us 6x squared plus 12xy. I'm now going to replace the y prime with 3x squared minus y over x plus 2y. And then that whole thing is times the x plus 2y. Nicely, that x plus 2y in the numerator and x plus 2y in the denominator can cancel. One of the reasons of distributing it in before replacing. I'm now going to distribute the minus sign through here. So that will be a minus 3x squared and plus y And then I have a minus 2, and I have a y prime that will be replaced, giving us a 3x squared minus y over x plus 2y, and all of this times the 3x squared minus y. And then this entire thing is over x plus 2y squared. So y double prime is equal to, we have a 6x squared, we have a 12xy. Let's distribute the minus sign in here. That will give us a minus 3x squared, a positive y, and then we have a minus 3x squared and another positive y. And then we have the last term, which is a minus 2 times 3x squared minus y times another 3x squared minus y, so that means it's quantity squared, and then all over x plus 2y. This entire thing divided by x plus 2y squared. Now we can combine together like terms in the numerator. The 6x squared, the minus 3x squared, and the other minus 3x squared will cancel each other out. We have a 12xy, and we have a plus y and plus another y, so plus 2y. What we will need to do is get a common denominator between those remaining terms and this fraction here. So I'm going to multiply this quantity by x plus 2y so that I can put this over x plus 2y, and it has the common denominator. I have minus 2 times the 3x squared minus y squared over that same common denominator, the second term, which I'm leaving alone. And then the entire thing is over x plus 2y quantity squared. So y double prime will equal to, and we have 12xy plus 2y times x plus 2y minus 2 times 3x squared minus y, and then that's going to be quantity squared, so I can times it by another 3x squared minus y. All of this over x plus 2y, after adding them together over the common denominator. And then the overall denominator can be written as a fraction and reciprocated and multiplied. So we have a 1 over an x plus 2y quantity squared. The numerator is going to be multiplying with a 1, so it will not change. Now what I'm going to do with the numerator is FOIL this out. So the first, I have 12xy times an x, which will be 12x squared y. Outside, 12xy times a 2y will be a 24xy squared. Inside, a 2y times an x is a 2yx. Last, a 2y times a 2y is a plus 4y squared. And then I have a minus 2 times, and I'm going to FOIL out these two with each other. First, 3x squared times 3x squared is 9x to the 4th. Outside, 3x squared times a minus y is a minus 3x squared y. Inside, negative y times 3x squared is a negative 3x squared y. And last, negative y times negative y is plus y squared. all of this will be over, multiply the denominators, we have an x plus 2y, which is to the first, and x plus 2y that's to the second. We add the exponents, x plus 2y to the third. So y double prime will equal to, we have a 12 x squared y plus a 24 xy squared plus a 2yx plus a 4y squared. And now we can distribute the minus 2. Minus 2 times 9x to the fourth will be negative 18x to the fourth. Minus 2 times the negative 3 will be a positive 6 x squared y. And again, another positive 6 x squared y. And the negative 2 times the y squared will be negative 2 y squared. All of this is over the x plus 2y cubed. Now we can combine together any like terms in the numerator. We have 1, 2, 3 x squared y terms. They can combine together. 12 plus 6 is 24 x squared y. We have the 24 xy squared. We have a 2yx. We have a 4y squared and a minus 2y squared, which will combine to be a positive 2y squared. And we have the negative 18x to the fourth. And all of this divided by x plus 2y quantity cubed, and there's the simplified version of our second derivative y double prime.